equation, which is fxy equal to 2x3 minus xy squared plus y squared plus 5x squared plus 3. So what we have to do first is we have to differentiate this original equation with respect to x. So it will become fx equal to 6x squared minus y squared plus 10x equal to 0. So basically this is our first equation. Then we have to differentiate our original equation with respect towards y. So it will become fy equal negative 2xy plus 2y equal to 0. So this is our second equation. Then we have to differentiate partial x with the respect to the x for the second time, which will it will become fxx equal to 12x plus 10, and we have to differentiate partial y with the respect to y, and it will become fyy equal to negative 2x plus 2. Then we have to differentiate x toward partial y, and it will become fyx equal to negative 2y, and differentiate y towards partial x, and it will become fxy equal to negative 2y. Basically, before this, we have got two equations, which is our first equation is fx and our second equation is fy. So from equation number 2, we will get 2y minus 2xy equal to 0. From this, we can factorize 2 and y, and it will become 2y 1 minus x equal to 0. So 2y equal to 0 and y equal to 0. So 1 minus x equal to 0, and x we will get 1. So we will get x and y point, which is it will become 1 and 0. These both point cannot be partnered together, or cannot be critical point, as it came from the same equation 3. Before this, we have got two points, which is 1 and 0, and we know that this point cannot be partnered together as it and cannot be counted as critical point, as it came from the same equation, which is equation number 2. So we can substitute point 1 and 0 into equation number 1. So when we substitute x equal to 1 in the first equation, we will get 6x squared minus y squared plus 10x equal to 0. So substitute x equal to 1, and we will get 6 1 squared minus y squared plus 10 to 0. So basically we will get 6 So we will get negative y squared plus 16 equal to 0. 16 equal to y squared and y equal to 4. So this is our first critical point, and it will become 1, 4. Then we substitute y equal to 0 into our first equation, and it will become 6x squared minus y squared plus 10x equal to 0. Then we will get 6x squared minus 0 power of 2 plus 10x equal to 0. We will get this after we substitute y into 0, and then we will get 6x squared plus 10x equal to 0, and we will get our x point equal to 0 and negative 5/3. So basically we have this y equal to 0, and we have two point of x, so our critical point will become 0, 0, 0, 0, and also another one is negative 5/3 and 0. After we get the critical points earlier, which is 1, 4, 0, 0, and negative 5/3 with 0, we have to do the second partial derivative test to know whether the critical point is either minimum point, maximum point, or saddle point. So the first thing first, the second partial derivative test have its own equation, which is d is equal to fxx times fyy minus fxy squared. So we have our fxx, fyy, and fxy earlier before. So we need to substitute all those equations using and substitute these 3 points into the equation given before. So for D, we have this full equation, which is fxx times fyy minus fxy squared, which means you have to multiply 10 times 2 fx times fxx times fyy minus fxy squared, which means these two will multiply themselves and minus with 0. That will obtain you D is equal to 20, which is greater than 0. So when D is greater than 0, there are two possible conclusions that we can make, either minimum or maximum point. So to decide whether it is a minimum or maximum point, we take a look at fxx value, which is 10, that is bigger than 0. So when fxx value is bigger than 0, we can conclude it as minimum value, minimum point. Okay. Next, we have to continue with other two critical point, which is 1 and 4. So the step is this. You just need to repeat the step, which is you have to substitute these 2 points, 1 and 4, into this equation. Like fxx, you substitute 1 into x here, and it will obtain you here 22. For fyy, you substitute 1 into negative 2, x plus 2 will get you 0. And for fxy squared, it will obtain you 64. So D here, which means 22 times 0 will get you 0, minus 64 will get you negative 64, that is less than 0. When D is less than 0, we can conclude it directly as a saddle point. Okay. For the last critical point, which is negative 5/3 and 0, substitute negative 5 over 3 into these two equations, it will get to negative 10, 16 over 3, and substitute 0 into this equation, you will get to 0. So the d you will get is negative 160 over 3, which is less than 0. So as I said before here, when the value of d is less than 0, it is another saddle point here. You can calculate it as a saddle point. So that's it. That is how we can calculate the extremum of function for this question. That's all from us. Thank you.